we are going to learn conversion from hexadecimal to binary. Now, a few things that we need to understand. When we say binary, we say base 2, and for decimal base 10, for hexadecimal 16. Why is that? Because if you look at here in binary, you can have only two numbers, like either 0 or 1, so we call it 2. When it is decimal, you can have from 0 to 9, numbers from 0 to 9. So you see, if you count from 0 to 9, it is 10. For hexadecimal, you have 16 numbers. 0 to 9, 10 numbers, A to F, 6 numbers. Altogether 16. When you are doing the hexadecimal, the decimal value for A, B, C, D, E, F is 10, 11, 12, 13, 14, 15 respectively. This is something that you need to memorize. It is super easy, like 0 to 9, and after 9 A, B, C, D, 10, 11, 12, 13, 14, 15. Okay, now let us take a number 45 AE. AE. Now, first thing we need to understand, one hexadecimal digit contains 4 bits. So there are how many hexadecimal digits? 1, 2, 3, 4. So 4 hexadecimal digits will contain 16 bits. Now, if you look at here, we need to get the binary for 4 hexadecimal digits. Now for 4, first you need to convert the hexadecimal into decimal, and we know how to convert decimal to binary. So the hexadecimal of 4 is equals 4, the hexadecimal of 5 is equals 5, A is equals, if you look at here, 10, E is equals 14. Okay. Now convert, this is the conversion that we learned from the another class, the converting from decimal to binary, converting from decimal to binary. So 4 divided by 2, quotient is 2, remainder is 0. 2 divided by 2, quotient is 1, remainder is 0. 1 divided by 2, quotient is 0, remainder is 1. Now look at here very carefully. 1, 0, 0, 1, 0, 0, and put 0 at the beginning. Put 0 at the beginning. In the same way, if you do 5, you get 1, 0, 0, and you put 0 at the beginning. Now, if you look at here, 0, 1, 0, 0, 0, 1, 0, 1. 0, 1, 0, 0, 0, 1, 0, 1. I will show you another way to find it. This is another way to do it. So if you look at here, we have 4, 4, 1, 2, 3, 4. Because this 4 is, in order to form a hexadecimal, we need 4 bits. So 1, 2, 3, 4. A hexadecimal 1, 2, 3, 4. E hexadecimal 1, 2, 3, 4. Now, when you get 4 bits, the table is 1, 2, 4, 8. Okay. 5, 1, 2, 4, 8. The formula is very simple, like 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Okay. So this is the formula with the binary table we did earlier, the conversion from binary to decimal. Now, if you look at here, let's come here and see. So for 4, we need to find the binary. Let's say our pointer is at 4 and our column value is 8421. So when we write this column, we write from right to left, but when we will start solving, when we'll start to find the binary, we'll go from left to right. Very important, when you write this table, 1, 2, 4, 8, 16, 32, 64, you write from right to left. Okay, so this is nothing but 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Okay, but when you start solving the problem, let's say 64, 32, 16, 8, 4, 2, 1, you start from right to left. Start from right to left. Okay, do from here, 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 whatever. Okay, now how we start solving the problem? If you look at here very carefully, the pointer value is 4 and our column values are 8, 4, 2, 1 respectively. So we start from left to right. The pointer is 4 and the column value is 8. We start from left to right, so the column value starts from 8. Now you need to ask, is 4 greater than or equals to the column value? If the pointer value is greater than or equals to the column value. If the pointer value is greater than or equals to column value, we put 1. So we can write here, if pointer is greater than or equals to column is 1, or else 0. Okay, now if you look at here, 4 is greater than or equals to 8, false, is 0. So 0. If the pointer value is still 4, column value will become 4. Greater than or equals to 4, yes, it's equal to 4. So we will write here 1. Now very important, once you write here 1, your pointer value will change. So the comparison that you have done with, you need to subtract that. What did I say? The value that you compared with the pointer value, we need to subtract that. So the pointer value was 4, the column value was 4. Subtract 4 minus 4 is 0. When the pointer value becomes 0, you already reached to the solution, put rest of them 0. So if you look at here, 0, 1, 0, 1, 0, 0. Okay. Now here the pointer value becomes 0, so rest of them will be 0. So rest we have only 1, we'll put here 0. Now multiply 0 with 8, 1 with 4, 0 with 2, 0 with 0, whatever you got 4. So this is the binary value. Let us do another one. The pointer value is 5, the column value will start with 8. Is 5 greater than or equals to 8? If 5 greater than or equals to 8, no. If it is no, then 0. If 5 greater than or equals to 4, yes. If yes, then 1. Now what you need to do, once we get 1, we need to change the pointer value. The pointer value will become 5 minus 4 is 1. The new pointer value is 1. We already have done column until 4. Now column value until 4. Now come, the column value will be 2. Is 1 greater than or equals to 2? 0. Now pointer value is 1. The column value will become 1. Is greater than or equals, right? So if it is greater than or equals, if it is true, then the value is 1. And after that, the pointer value will get changed. So subtract the pointer value from the compared value subtract the compared value with the pointer value, then you'll get 0. Once it is 0, you reach the solution. So if you look at here, 0, 1, 0, sorry, 1, 1, 0. So if you look at here, so you can write here, the first one is 0, then the second one is 1. So if you look at here, the first one is 0, the second one is 1, the third one is 0, the fourth one is 1. Okay. Now the same way, if you want to do A, first of all you need to find the decimal value of A is 10. So you already know how to find the you know that how to find the binary, but we are going from hexadecimal. However, we need to find the decimal value because we need the pointer value. The pointer value is 10. We'll start the column value with 8. Compare, is 10 greater than or equals 0? That's right. Then the binary is 1. Now you need to change the pointer value. 10 minus 8, you compared with 8, you get 2. The new pointer value is 2, the column value is 4. Is 2 greater than or equals to 4? No. So it will become 0. Now pointer value is still 2 because last time we got 0, the column value will become 2. 2 greater than or equals to true. Then the pointer value is 1. Now the pointer value, whenever you get the binary 1, you need to change the pointer value. Pointer 2 minus 2 is 0. Okay, so once you reach 0, so that is where is the solution. So it will become 0. Okay, now let's take a number 192, which is a decimal number. So if you do the 192, you will get this one. Okay, follow the previous procedure, you will find the binary, which is this one. Now let's do this one. So if you look at here, this is an IP address 192.168. So you know that this is a decimal. So for this IP address 192, you have got 8 bits. This is the first octet, this is the second octet, this is the first octet, this is the second octet, this is the third octet, and this is the fourth octet. Now there are 8 binaries. So you look at here, 8 binaries. So you need to draw the table with 8 binaries. The formula is 2 to the power 0, 1, 2, 3, 4 until 7. And if you write the value is 1, 2, 4, 8, 16, 32, 64, 128. Okay, you can memorize this one. Now, is 128, is the pointer value, which is 192, pointer value 192 is greater than or equals to column value is 128. Yes, so the value is 1. So you got here 1. Now the pointer value will change. 192 minus 128 is 64. Now the pointer value is 64. If the pointer value is 64, which is greater than or equals to 64, because the next column value is 64. Yes, so the binary is 1. You put here 1. The pointer value will become 64 minus 64, which is 0. Once the pointer value becomes 0, you already reach the solution. Here everything will be, rest of the things will be 0. Now if you multiply 1 multiply 128, is 128, 1 multiply 64 is 64. If you add them up, you will get 192 as decimal. Now here you see you did the same comparison, 192 greater than 128, then the what is the then you get 64, 64 minus 64. Okay, we have already done that over there. Okay, now in this step, so if you look at here very carefully, once you get here, once you got the result, so if you write 45 AE, this is the one that you need to write as binary. 01000101, okay, 1011. So you need to write them together, then which will be equivalent to 45 AE. Now, from hexadecimal to decimal. Last time we got hexadecimal to binary, hexadecimal to binary. So this is the binary one, 0101 for 45 AE. Now, from hexadecimal to decimal, we will always start from right to left. Right to left, EA5 4, right to left. The value, the decimal value is 14. This is the decimal value for each individuals. 14, 10, 15, for 5, 4. Now you need to start with the power of 16. 16 0. So you have 16 0, 16 to the power 1, 16 to the power 2, 16 to the power 3. So write them sequentially. After that you multiply 14 with 16 to the power 0, 10 into 16 to the power 1, 5 into 16 to the power 2, 4 into 16 to the power 3. Once you have done the multiplication, if you add them, you will get 17838. 17838. So for this is the decimal, this is the hexadecimal value, and this is the decimal value. Start from right to left, write the individual values, and after that multiply each of them individuals with 16 to the power. Add them is the total decimal value. Now I will show you another way where you convert hexadecimal into binary. Okay, where you convert hexadecimal into binary first, and after that from that binary you convert to the decimal, and after that from that binary you convert to the decimal. Okay, now the first thing is what I said here. We directly converted hexadecimal to decimal, and you need to know, like, you need to do this conversion. Okay, 16 to the power. Now we are going to convert hexadecimal into binary. We already know the hexadecimal into binary conversion, how it is done. Now if you look at here, how many hexadecimal digits we have here? 4. That means we have here 16 bits. So for 8 bits we had a table, right? 2 to the power 0, 2 to the power 1, 2, 3, 4, 5, 6, 7 until 7. For 8 bits we had this table. For 16 you need more 8. So it will be 2 to the power, like, more 8. Now for 8 we had 1, 2, 3, 4, 5, 6, 7, 8. Like 1, 2, 3, 4, 5, 6, 7, 8 until 2 to the power 7. I do here is until 2 to the power 7. Now we have more 8. So 8 plus 8 is 16, but they're together. Then 1, 2, 3, then 9, 10, 11, 12, 13, 14, 15, 16. If you put the binaries accordingly, you will find the binaries this way. Now you do the multiplication. 0 multiplied to the power 15, which will be, so 2 to the power 15 is 32768. 0 multiplied to the power 15 is 0. Then 2 to the power 14 is 16384. 1 multiplied 2 to the power 14 is 16384. Then 0 multiplied 2 to the power 13. 2 to the power 13 is 8192. 2 to the power 12 is 4096. So if you look at here, 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 81, 90. It always gets double, right? So now you put the binaries, do the multiplication with that, and you will get something like this. And if you add all of them, all the 16 values, you will find 17838. So this is another way of doing it. Depending on what number you have, okay, how many hexadecimal digits you have, you can calculate. Okay, whichever way you prefer, I did show you in both the ways. Okay,